Okay, in this video I'm gonna create a twisted spiral ball and something like that using mostly Vex. Okay, now first I want to make a spiral curve along the sphere. So I'm gonna make a line first. First make a geometry. Then make a line. And let's set up some parameters first. I'll make a null component. I'll name it controller as always. And let's set some parameters here. First I need a radius for the sphere, so I'll type radius. Ranges from 0 to 10 is fine, I think. And some resolution for the spiral curve, like how many points you want for this curve, so that more resolution you have, more smooth the curve will be. So I'll set this from 0 to 500 and make this integer. And I'll also make a parameter called cycle, which stands for how much the spiral rotates. So if it's 2, then it rotates like 2 times 360 degrees. So I'll set the range from 0 to 10. I'll just make a float number, and also let's make a parameter called pipe, which stands for the pipe radius that I'm gonna twist later on, and make the range from 0 to 1. And also let's make a parameter called twist, which stands for the angle, how much it will twist for each point. I'll set up the range from 0 to 1 as well. Then finally I'll give a integer parameter called num spiral to set how many spiral curves you want along the sphere. Let's set it from 0 to 10 and apply, and I think that's all I need for the parameters. Let's say OK. Let's set default value here, like 1, 300, 2, 0.05, 0.025, and 6. Okay. Now let's start making some spiral curve along the sphere. Now first I need to set the length of the line here from the parameters, which will be this radius value. So I'll copy this and set it to the line length. Yep. So if I change the radius here, it will increase like this. Okay. Now next, let's resample this curve. Right now I just have 2 points from the first and the end of the curve, so I'll give a resample node here And let's make a expression here on the lengths. First I need to get the now I would like to get the length of the curve here for the resample, so I'll just copy this radius value here, or I'll just copy this parameter, copy parameter and paste reference divided by, and I also want the resolution here, which stands for the number of points. So I want to divide the length by 300, which will give you 300 points on this resample length. Let's copy this here, paste it here. Now I have tons of points here, 300 points I guess, 300 or 301. Let's check. Yeah, I have 301 points. Okay, that's good. Now let's make a wrangle, point wrangle, to actually rotate this, move these points like a spiral shape using cosine and sine trigonometry. And first I need to get the angle, which you can calculate using the cycle. So first get the parameter from the cycle variable here, cycle parameter here, times number of points divided by the total number of the points. And also need to set the angle for the, so this will be 360 degrees in radians, and you divide the point number by the total number of the points and times the cycle, which will make the angle value for how much it should rotate with using the cycle value based on the cycle. So if the cycle is 2, it's in between 0. The first point will be 0. The last point will be 720 degrees. Okay. Now that you have the value here, angle value here, let's change the point value, the x and z. I just want to move on the x and z direction, xz plane. So the x will be 2 times. Doesn't have to be 2, but bigger value is good, I think. Since the radius is in between 0 to 10, so let's make the value, the maximum value to be 10 times cosine angle p. The z value is 10 times sine angle, and if you see the result, yes, I get this spiral, which looks really big, but I'm gonna shrink it later on, so it's no problem. And let's set an attribute for this each point called direction to be the vector that goes from the point itself to the center on XY plane, which faces all the points will face on the center. And let's see the parameter here. Yeah, I have direction parameter here, attribute here. So now now let's give a sphere and to actually project these spiral curve. Now I need to set the size of the sphere, which you can use the parameter, which is this one, the radius. So let's copy the parameter here and paste relative reference, paste relative reference, paste relative reference. Okay. Now, in order to project the spiral curve on the sphere, I'll use the ray. Now the curve will come to the first input, the sphere, which will be the collision primitives, will come to the second. And I think the primitive type as a primitive is fine. Let's see, and I need to set the ray direction to be not normal, but using the attribute called direction. Okay, now I have a problem here. This is because the endpoint is on the last point, and somehow it's not projecting correctly, so I have to shrink the line a little bit. And I also need to increase the length of the line so that it will cover the bottom part as well. Or just raise the sphere a little bit, like half the radius itself. So let's make the length to be the radius times 2 minus 0.02. Okay, and for the sphere I will raise the center y by radius. So copy the radius parameter and paste it here. Okay. I still have some problem here. I think I need to do something with the line. I think I need to move this line a little bit to upward by 0.01. Okay, okay. This is good. Then it's projected nicely. The spiral curve has been projected nicely on the sphere. Now, right now if I look at the normal vectors, I don't see any values, and what I want here is the normal vector that is facing, that is directing on the tangent direction for each point based on this curve, on top of this curve. So in order to get that, I would need a poly frame, which you can use it to calculate the tangents value. I just need a tangent, and let's name it n. Now it's facing, now the tangent vector is facing, directing on the tangent vector of the each point on the curve. Now that's good. Next, let's give a attribute to each point in order to make a twisted loft polygon. So basically, first I want to have a section curve for the twisted loft object. I'll using circle as a base. And for the circle, I already have a parameter called pipe, so I'll copy this parameter and set the radius to be the pipe. And here you have the pipe, the circle with a pipe radius. And let's make this a nerves curve, and right now the division is 12. I'll just make it 10. 12 is also fine, I guess. And since I want to show the twisted effect, the circle itself doesn't show the twisted effect, so let's just move the points on the odd number. So in order to do that, let's make a simple point wrangle. And if the point number is a even number, then the position of the point is times change the position of the point by multiplying by 4, which will give you some star-like shape. And I do see a bit weird things here. think it's because it's nerves not showing the geometry correctly, but I think it will be gone if I use the loft, or in this case I'm using sweep function, I think. So let's skip a sweep node, and on the first input let's put a section here and make the point collection of the points onto the second input. Okay, now right now it's just copying the section to each point, which is not what I want. I want to make a tube, like star sections tube. So I think I need to set the sweep to make the output skin, which you can set it using here, this option, I think, skin unclosed. Okay, now it's good. Now it's kind of a twist in already with weird position, but I'm gonna correct it later on. Right now, it's good that it's making it pipe, the sweep object. Now to make the pipe to be twisted regularly using the parameter I set it here, I'll put a new point wrangle in between polyframe and the sweep, and let's add some attributes to each point on this spiral curve. Now first I need an angle, which is a same value, kind of a same value as the one that you set it here, but not exactly the same. I'll just copy this here. Wait, I'll just copy the angle from here on the first point wrangle, which I used to make a spiral curve, and paste it here. But the problem is right now this value gives me the range between 0 to 720, which is a bit big. So let's decrease the value, change the last value 2 to 0.04, and the first variable, the first attribute I want to set to the point is a p scale to change the size of the section for each point based on the angle value. Now let's use the cosine and angle, and the cosine angle should be in between -1 to 1. Let's set the goal radius to be in between 0.2 to 1. Now if I look at no, I don't really see the result yet. Or am I seeing it? No, I don't think so. Let's see if I'm adding the parameter correctly. Okay, I do have point scale here, but there is a problem here. It's not really changing so much. It's in between 0.98 to... So I think I need to fix the fit range, I guess. So I think I need to change the parameter. Okay, I think I still need to set it to 2. Okay. Oh yeah, it does make sense with making it exactly the same as the first line radius. Okay, now it's good. The other attributes that I want to add is the rotation of the section so that it will twist with constant angle. Now in order to twist using the sweep, I need to set both n attribute, which I already have, is a tangent vector, and I also need a up vectors, and together I should have a information for the plane to be used for the rotation for this cross section curve. So it's a bit hard to understand, but first I need to make a matrix. Let's call it up matrix to be indent. Ident. And rotate the app matrix use by 90 degrees, which is pi times 0.5, and based on the y-axis. No. And set the app vector to be the nx, getting the normal vector x, and set the height to be 0 and use the z value as it is, and multiply it with up matrix in order to so that it will rotate using the up matrix. Which will give a base axis in order to rotate for the final matrix. So for the last thing you need to do is to make a new transform for the matrix and make transform and use the up vector and the n tangent n. And last of all, rotate the transform using the pi times pt num times using the twist parameter. And based on the n-axis. Okay, I'm getting an error because... okay. And last, I'll update the up parameter by multiplying with the transform, which is the rotation, which is a rotated matrix, so that the up vector will be rotated. And if I done it correctly, I think it's twisting as I assumed. Yes. Yes, yeah, it is twisting. Well, I think it's a bit hard to understand with these calculations. I'll just commenting this out and make a new visualize marker called up, using the up attribute. Let's color this red so that you can see it clearly, and I'm enabling it. And I am not seeing it because I think I need to set up need to set this to vector. The marker color to be red. Close. Okay, it's a bit too big. But now that you can see that the let's comment this out. Let's now the first up vector is that the point, the vector itself is pointing on the center from the point position, like this. And I am making a new transform using the tangent vector and the vector that goes from the point position to the center on XZ plane, and I am rotating this transform, meaning the plane, using the tangent vector as a axis and rotating the plane, the plane based on the tangent vector, and the up vector that goes to the center, and which will give you the matrix, rotated matrix, and use that matrix to update the final up vector, which will give you the twisted up vector like this, so that you can use the up and the n vector. It'll be used automatically in the sweep to twist the cross section. Yeah. Yep. It's good. Now Last, let's cap this sweep object. You can do that because it's a nerves object. It's not closing as I suspected, so maybe I don't need this. Maybe I'll just keep it as it is. And convert this object to nerve, no, polygon. Yeah. What if I put the caps in between? What will? Yeah, it still gives a not so good. What if I change this to polygon? Well, it doesn't give you the cap at all, so I'll just keep it nerves and I don't use the cap here. And I have converted it to polygon. Now let's attach a normal to make the normal of the face a bit smoother. Yeah, looks pretty good. And I'll pack this primitive. And last of all, right now one spiral line is a bit sad. It's not that enough. So let's make a for loop to add several more spiral curves by rotating each curve, base curve by the angle, which will be created by using the num spiral parameter. So I'll copy this parameter here and give a transform value, and let's rotate this. Let's see which parameter I need to. Okay, I think I need to change the Y rotation, so I will give a 360 divided by base relative value, and I want to merge each iterations, yeah, which will give you 6. No, right now it's given 10, so I think I need to give a parameter 6 here as well. Yep. So now I have 6 copied spiral curve rotated based on the which looks like aligning to the sphere, and if I change the parameter here, yeah, I have as many twisted pipe as I want. Now this will be the final output, but in order to make it more interesting, let's animate this. Okay, so in order to animate it, what I can do, maybe I want to give an effect that the scale and the twist of the cross section to be raised up like continuously. So in order to do that, first I need to set the angle here. which is used for the P scale, the scale of the section. So what I can do is to use the frame with the angle, something like this, so that the angle will change using the frame. Yeah, like this. Also, I want to change the value for the twist thing, so I will put a similar parameter value here, frame times pi times 0.04. Yeah. So finally I have a something like twisted orange peel. Its color is orange. Oh, not this color. Orange. Okay. Now let's set the frame to be 200 and play. Yep. This is it. Twisted peel. It's done. Okay, and Q.